Now, dear student, chapter number 8, Gravitation, and today we have the topic Gravitational Potential Energy and Expression of Gravitational Potential Energy. So, the gravitational potential energy of a body is the energy which associate with it due to its position in the gravitational field. And definitely here we are talking about the gravitational field of the Earth. Or it can be simply expressed as a amount of the work done to carry an object or the body from infinity to a particular point inside the gravitational field. Okay, or inside the gravitational field, the amount of the work done to carry a body from one place to another. So the energy is associated with a body due to its position is called the gravitational potential energy. And definitely it's a concept of the energy. So whatever the basic assumptions we are just taking with the energy, so we will also put here. And what is the basic formula which we have needed to discuss this one, gravitational potential energy. So we are just framing that one. Okay, so here just we are just discussing the basic formula. Now here we have taken the one of the basic diagram. This is the center of the earth of mass m is there, which having its radius that is called the capital R is there. And one of the point which is situated where we want to take on a object of the mass small m, which is be situated at the point A, and we are just taking this one object at a point P, which is at a distance R from the center O. Here we are just assuming that OP is the simply the R is there, and we have the R is greater than 2 capital R is there. Okay. Now we are just taking a small displacement of an object from A to B that can be given by the small dx is there. So we are just doing the small amount of the work done. Okay. So to make the this one computation of this work done, we are just approaching a limit from infinity to R is there. Okay. Now we are just approaching a simplest formula. Here we can make the simplest assumption from this diagram. Here we have that OA is equal to X is there. Okay. OP is nothing but it's a simply the R, and we are just taking the object that is in the part of the limits R we have of the position, that mean infinity to R, which we want to paste here. Okay. As we are just doing the work done from where to where, so I am just taking the meaning of the work done from infinity to a particular R at a distance R, which is inside the gravitational field is there. Okay. So we can start with the part. Now the small amount of the work done to carry an object from A to B, that is dw is equal to f dx is there, where the meaning of the force of attraction between the capital M and the small m is that f is equal to g capital M upon x square is there. Use the equation number. Now the total work done from infinity to R. So here we are just approaching the limit. Now in the left hand side we have the limit 0 to W, dw is there, and we are just approaching a limit infinity to R, capital G capital M small m x square, and with the relevant integral that is called the dx is there. So this is the one of the equation number 4 we have, as we are just solving this one equation. So it comes that work done from infinity to R is there, that is called the capital G capital M, and is these terms can be kept outside the integral, and we are just getting 1 upon x square dx is there. So work done from infinity to R, that is called the capital G capital M small m, and the relevant integral of this part, that is minus 1 upon x from infinity to R is there. Okay. So this is the one of the basic portion we have. Now we have the we are just approaching the limit, so we are just getting that W infinity to R is equal to minus G capital M M upon R is there. Okay, so this is the one of the general formula. Equation 5, equation 5 represent potential energy of object of mass m in gravitational field of earth of mass capital M at a point P which is at a distance r. So this is the kind type of the formula we have for an object due to its position inside the gravitational field. Now what are the basic assumptions and the facts we can discuss by this formula? So we will utilize them. Now one of the formula we have. Now in this formula we are just getting the negative sign. So what is the relevancy of the negative sign is there? We are just asking that it is a now this work done is done by the force under the action of a gravitational force. So it indicates that the potential energy due to the gravitational force of attraction. The negative sign in equation 5 indicate that work done or the potential energy is due to force of attraction of earth. As we are just increasing the value of the r, then potential energy increases and it will be less negative and become at r is equal to infinity there. Okay, as we are just keeping the r is equal to infinity in the particular formula, so we know the gravitational potential energy can be stated as minus capital G capital M small m upon r. As we are just keeping the r is equal to infinity, so the gravitational potential energy will become the zero. Okay, so this is one of the representation we have. As we are just taking a body from distance r1 to r2, then we have the general formula, and whenever we are just solving it, so it comes in the part of that capital G capital M small m. As I am just completely solving it with the approaching of the limit is there, so I am just getting 1 upon r1 minus 1 upon r2. So this is the one of the general formula we have. As we are just making the concern that r1 is greater than, R1 is greater than R2, that makes the concept that delta U will be the negative is there. So we can make the assumption when a body is brought closer to the surface of the earth, its potential energy decreases. When body taken closer to the surface of earth, its potential energy decreases, but you must consider this one fact that but it will be more in negative manner, more in the negative manner. Okay, more negative we can take here concept. This one, these are the general assumptions. Now we can add more here. Now the unit of the gravitational potential energy, so we are just assuming that u, or the work done from one place to another place, that is called the G capital M small m upon R. Okay, so here I am just taking the standard nomination regard inside the gravitational field of the earth. So whatever the unit and finalized unit we have, that is called the joule is there. And we can easily understood that joule can be abbreviated in the part of the Newton meter. So kilogram meter per second square is the concept of the Newton we have, and the meter is there. So this is the simplest abbreviation we have, and on behalf of this concept we can also make the assumption about the dimension. Now gravitational potential energy is a scalar quantity. Okay, so these are the some basic assumptions those have required to discuss the gravitational potential energy. So simply the amount of the work done to carry an object from one place to another place inside the gravitational field. This work done is associated with this body in the part of the gravitational potential energy, or simply the energy associated with an body or an object due to its position inside the gravitational field is called the gravitational potential energy. And we have discussed one of the basic formula that is called the capital G capital M upon R, where the capital G is the gravitational constant we have, and the capital M is the mass of the earth. So we are just talking largely in the concept of the gravitational field of the earth. So how can we discuss the potential energy of any body? And it is the mass of an object we have, and this is the kind of the distance from the center O where we want to take an object. So we want to make the conclusion about the how much potential energy is associated with this object. Okay, so these are the basic concept of the gravitational potential energy, and so many numericals we have, so we can discuss them.